now we get to actually take a step back and start at the beginning, because before we can talk about some of the more complex issues which involve interactions between molecules reacting, or even when we're talking about individual molecules, the bonds that form between individual atoms. Before any of that, we actually need to establish a way that we're going to describe and think about how an individual atom behaves. And the way that we'll do this is starting with talking about the discovery of the electron and the nucleus here. Once we go through that, we will be able to talk about describing an atom using classical physics. So once we have an atom and a nucleus, what we'll try to do is apply the classical mechanics to explain how that behaves. What we'll find is that this fails, and once this fails, we're going to need another option. Luckily for us, we have quantum mechanics, which we'll be talking about for the next few lectures, and we'll dive into that. We might get a chance to introduce it today, but certainly in next class, we'll be introducing this new kind of mechanics that's going to allow us to describe the behavior of atoms. So I want to point out that it makes a lot of sense for us to start with the discovery of the electron and the nucleus, because it really highlights one of the big issues that comes up in all chemistry research that you do. And that is, how do we actually study, or in this case, how do we discover atoms or subparticles that we actually can't see at all? And there are lots of solutions that chemists come up with. There's always new techniques that allow us to do this, and these are just some of the first, and we'll go through them in a little bit of detail here. So this all starts in terms of putting it in its historical context at the turn of the century. We said we'd start right in on the 20th century of where chemistry was. And where we were at the start of the 20th century in the late 1890s is that we were at a place where there was great confidence in our understanding of the universe and our understanding of how all matter worked. So people in the chemistry community and in the physics community had this general feeling that the theoretical structure of the entire universe was pretty well understood. And they had this feeling because there had just been this huge boon of discovery, of scientific advances that included Newtonian mechanics, and included Dalton's atomic theory of matter, also thermodynamics and classical electromagnetism. So you can understand they really felt quite confident at this time that we could explain everything that was going on. And in fact, a really telling quote from the time was said by a professor at the University of Chicago. And what he said is, our future discoveries must be looked for in the 6th decimal place. So basically what he's saying here is, we pretty much understand what's going on. There's nothing new to really discover. All we need to do is measure things more precisely.